The entire American space program once balanced on the wings of a single machine. This vehicle, the Space Shuttle, was designed to make accessing orbit as routine as an airline flight. For 3 decades, it mostly succeeded, launching astronauts, satellites, with a regularity that became familiar, even mundane. But this very success masked a profound and systemic vulnerability. By concentrating all human spaceflight capability into one complex, reusable design, NASA had created a single point of failure. When that system faltered, as it tragically did, the entire enterprise ground to a halt. The shockwaves were not just technical, they were cultural and political, exposing a fragility hidden in plain sight. The common narrative holds that the Space Shuttle was conceived to lower the cost of space access. The core promise was reusability. By designing a vehicle that could launch like a rocket and land like a plane, NASA hoped to fly dozens of missions per year, dramatically reducing the price per pound to orbit. This was the explicit goal, the one presented to Congress and the American public. It was a powerful vision, justifying an immense national investment. The shuttle became a symbol of American ingenuity. A sophisticated, next-generation machine that would domesticate low Earth orbit. However, this focus on cost and reusability is an incomplete picture. The shuttle program was also a political anchor and an industrial anchor. After Apollo, a large, long-term project like the shuttle maintained momentum, expert teams, and contractors. It distributed jobs and high-tech investment to key districts, with effects far beyond the launch pad. The shuttle was not just a vehicle, it was an ecosystem. In the early 1970s, NASA stood at a crossroads. Apollo had achieved its goal, but the program's massive budget was unsustainable. The space transportation system, centered on the Space Shuttle, won out. The shuttle was pitched as a reusable spaceplane, a multi-purpose vehicle meant to make low Earth orbit affordable and routine, serving scientific users, commercial users, and military users. The design was a marvel of compromise and ambition. Reusable orbiter, large cargo bay, disposable external tank, 2 reusable solid rocket boosters, a hybrid approach, rocket performance plus aircraft reusability. The promise: a fleet flying up to 50 missions a year, slashing launch costs. A massive industrial mobilization followed. Rockwell for the orbiter, Martin Marietta for the external tank, Morton Thiokol for the solid boosters. Specialized factories rose. A nationwide supply chain emerged. From delicate thermal tiles to complex main engines, this concentration of resources and expertise created a technological monoculture. Industry learned to build a spaceplane, not a diverse fleet of simpler expendable rockets. For 30 years, the dominant model was locked into a single complex architecture. Enjoying the analysis? Tap like so more viewers find it. Drop a comment with your alternate shuttle timeline, and subscribe for our next scenario. If the Space Shuttle program had been canceled in the mid-1970s, the most immediate effect would be a void in NASA's human spaceflight plans. Without its designated workhorse, the agency would scramble for an alternative. Most likely, evolve Apollo technology or build a simpler capsule. Instead of a winged spaceplane, NASA would pursue a capsule atop an expendable rocket derived from Saturn or Titan families. Billions freed from shuttle development would flow to a capsule program, with the remainder boosting planetary probes, Earth science, and aeronautics. Shuttle-specific factories become stranded assets, forcing layoffs and write-downs. Firms strong in expendables and re-entry vehicles rise. Contract geography shifts, triggering congressional competition for replacement work. Instead of one monolithic program, multiple smaller projects vie for favor. More distributed, but more contentious. It would have been a very different scramble, less grand at first, but fast to reconstitute capability. Without the shuttle as the primary model, the pursuit of a complex, winged, reusable vehicle would be sidelined. Focus shifts to optimizing simpler, more modular systems. Core challenges: mass-producible engines, dependable staging, robust capsules. Volume learning lowers cost faster for Titan Delta-class rockets. Launching satellites and cargo becomes more affordable sooner. A market for frequent, reliable, moderately priced launches establishes earlier, nurturing commercial entrants. The shuttle concentrated risk. A diverse, expendable fleet distributes it. A failure may cost one rocket and payload, but doesn't halt the entire program. Investigations target specific engines or avionics. Fixes flow quickly without multi-year stand-downs. Skills tilt toward lean manufacturing and stage integration, not orbiter maintenance. Ground infrastructure proliferates pads instead of massive processing hangars and runways. By the 1990s, the industry resembles a forest of smaller, hardier pines, competing for light, collectively more resistant to storms. A single, high-profile program acts as a political lightning rod. Its successes triumphs, its failures national tragedies. The loss of Challenger in 1986 led to a nearly 3-year hiatus as investigations proceeded and culture was examined. One point of failure created systemic brittleness. In a world without the shuttle, risk spreads across different rockets and capsules. An accident remains serious, but investigations localize to one vehicle. Others, after review, continue. Oversight pivots from one all-encompassing inquiry to multiple focused technical reviews. Funding turns granular. Congress can defund a weak link while backing stronger alternatives. Safety culture evolves through frequent smaller lessons instead of rare, system-wide shocks. The system becomes less brittle, its momentum less easily broken by a single tragic event. If this thought experiment is useful, click subscribe so you don't miss the next one. Tell us which mechanism surprised you most: budget, industry, or safety. Imagine the Space Shuttle's massive cargo bay. Its heavy lift capability directly shaped the International Space Station. Large truss, expansive modules built to fit the bay. Without the shuttle, a different, more modular station would emerge, assembled from smaller components on various expendables. That architecture encourages earlier international participation: Russia, Europe, Japan. A smaller, more automated station prioritizes materials, science, and tech demonstrations over extensive human biology experiments. Without shuttle servicing, telescopes like Hubble are designed for greater redundancy instead of astronaut repair. The result? More robust but less flexible observatories. A government-operated shuttle suppressed commercial markets. Without it, NASA becomes a customer earlier. NASA buys astronaut and cargo rides on private rockets, creating a stable market for reliable, cost-effective launch services. The new space revolution might start in the 1990s, part of the shuttle dividend funds an earlier return to the moon, or foundations for Mars missions. Humanity's expansion timeline could shift, accelerated by a generation not locked into a single orbital vehicle. The central lesson is not that the space shuttle was a mistake, but that it embodied profound trade-offs. It enabled magnificent feats of orbital construction and saved Hubble. But it sacrificed systemic resilience, suppressing competition and tying destiny to one vehicle. Powerful, yet brittle. Centralized, and vulnerable. The alternative favors redundancy over singular capability, incremental progress over giant leaps. Big machines rewrite incentives, skills, and who gets to build. The shuttle's absence would not erase spaceflight, it would rewire it from the ground up. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.